Vibe coding, all the rage these days. But occasionally, also a source of rage. Because the fact of the matter is this: you don't know what you don't know. Meaning, if you aren't a trained software engineer with a decade or more of experience, you've probably got some gaps in your understanding of things. So in this video, I thought I'd put together a list of 21 tips that help you take one step or 21 steps closer to ultimate vibe coding glory. Meaning, if you stick through to the end, you'll be that much closer to the amazing vibe SaaS of your dreams. So if you're already a subscriber, welcome back. If you're new to the channel, my name's Sean. I try to make AI and vibe coding easier and simpler and more effective for people like you and me. And I draw my experience running actual businesses that use this stuff to do that. So in this video, we're going to go through my 21 tips, talk about what each one is and why I think it's important for you to know. So this is going to be great for you whether you are a beginner or even if you're more experienced and just love to learn and are wondering if there might be something in this list that you didn't know yet. I say it a lot on this channel, but when a technical skill starts to become a commodity, meaning everyone can do it, everyone has access to it, you have to ask yourself, what will separate you? And understanding what you are doing is what will separate you, and it will become a premium that people will pay for. And so my goal for this video is that at least one of these tips actually helps you improve your process so that you can ride off into the sunset on your SaaS unicorn. And so last thing, throughout this video, I may reference or show you different prompts or multi-step processes that I use, all of which you can grab for free inside of my school community down below in the comments. So tip number one, using widely documented tech stacks. Now, this is a tip you hear a lot, but it is worth repeating. LLMs like Claude are trained on specific code examples. So when you use a widely documented technology or tech stack, you're already at an advantage because odds are someone has already encountered the problems you are running into and have already documented solutions to those problems, which means the AI is a lot less likely to hallucinate solutions that don't actually work. This is actually a big reason why I believe that traditional software developers and engineers will always be needed, because someone's got to build the initial solutions that the AI then becomes trained on that we all then get to go in and use. Someone needs to do that. So if you want less headaches and a faster time to having up and running apps, use a stack that people already know and love. Tip number two, planning extensively ahead of time. I personally use a 4-step planning process before I even write a line of code. Here's why this is important. LLMs are not that good at architecting complex solutions while also implementing the code at the same time. At the end of the day, they are limited by how much context they can handle. So really good at solving narrowly defined problems. So you want to really spend 60 to 70% of your time in the development process in the planning phase. And this is how real world software development actually works. Meaning, what tech stack are you going to use? Where in the code base will you actually use it? What gaps in your understanding of what it actually takes to build this project might there be that you're not aware of yet? What are the main requirements of each of those features? Like what needs to be in place so that you can look at it and say, yeah, hey, this thing actually works the way I intended it to. This is awesome. What are those lists of requirements? Once you have that first step complete, you need to move on to the second stage of that planning process, where we're building out robust feature documentation. What are the API endpoints? What are the payloads they accept? What does the database schema look like? What is the logic of the different components that use those different endpoints? What are the complete user stories from A to Z? How do they actually interact with this thing? What is it meant to do? How is it meant to maintain its state? After you've done all of that, you can move on to steps 3 and 4, where we start designing and then doing detailed granular task planning. Again, full guides on all that stuff inside of the free school group if you want it. But the reason that step is critical is because we don't start that process until the entire app is really well defined, down to like very small details. Because once we've done that, the actual writing of the code becomes a lot easier. Tip number 3, use your context wisely. Inside of most AI-powered development tools, you have these little tiny @ symbols that say something like add context. And what these allow you to do is they allow you to pass context into the prompt. And so this is critical because LLMs have maximums on how much context they can process at any given point in time. If I tried to pass, for example, my entire code base with every request, it would get way out of control and it would miss all of the detail that I'm looking for. And so you want to control what level of detail you're passing in every time you ask it to do something. And so this does two things. Number one, you make sure that it actually has the information it needs in order to answer the question or answer the prompt. Number two, you're making sure that it's using all of that processing power that it has to solve a very specific problem with all of the information that it needs to solve that problem. So certain IDEs try to do this for you automatically, like Windsurf or Cursor. When you come in here and you type something out, like update my app to do XYZ, it is going to go through and it's going to try to determine what the context is that it needs in order to solve that problem. But at the end of the day, you know best what that is. So you should come in and actually add that context. If I was in this project and I knew that inside of this component directory are where all of my screens that I've designed live, well, then I want to make sure that I am passing this folder in when I make a request that has to do with these components and how they function and how they interact with each other. Because now it doesn't need to go searching and it's not going to miss things that should be there. So you want to always be conscious of what is that context behind the prompt, especially if you start seeing your responses degrading in quality. You want to ask yourself if you are bogging down the context. So tip number 4, commit between conversations. One of the biggest casualties of vibe coding is that the practice of committing changes is kind of dying off with beginners. Committing changes is pretty simple to do, and what it does is it creates a snapshot of your code. Meaning, if anything were to ever break, you can just roll back to a point in time where things were actually working. It also means that you can work on different features at the same time and then merge them together as they are ready. So my tip here is this: get in the habit of at least committing your changes between conversations. And if you don't really know how to do that, you can come through and you can ask your tool. And so there we go. We have a command that was generated for us by the system. So again, get in the habit of doing that between conversations, because for most vibe coders, a conversation coming to an end is like a natural breakpoint where you would want to commit your changes anyway, right? If you're like me, when you're done with a new feature or changes that you made to an existing feature, you move to a new conversation. So it's a natural point to make that happen. That way, if you ignore tips 9, 18, and 21, you can at least revert back to a version of your app that was actually functioning. Tip number 5, commit solutions to the system memory. Nothing is worse than struggling through the same problem twice. You bash your head against the wall for hours and hours and hours trying to fix some problem that seemed like it was above your expertise level, and finally you break through and create a solution that works. And then tomorrow, when you're working on a new feature, you run into the exact same bug, but now you can't solve the problem the same way. And you are back aboard the struggle bus. And so one way we can overcome that is by using memory. Most AI-powered IDEs natively support some sort of memory system, or they at least support MCP servers that are memory servers. Meaning, anytime you come up with a solution to a significant problem, which could be as simple as app styling or how you like to debug certain things, you commit it to memory. And then those memories persist across the project or even across multiple projects. Meaning, if you're using those similar widely documented tech stacks in each of your projects, you're going to spend a lot less time reinventing the wheel. Tip number 6, ask the system for multiple perspectives on your problem. Sometimes you ask Cursor or Windsurf or C-Line or RuCode to answer your problem or fix your problem, and it doesn't get it exactly right. Or maybe it just is still broken. What I like to do in these situations, when something seems like it's more complicated than I would like for it to be, is that I ask the system to give me 3 different approaches to solving that problem and explain why the approach is valid and why it might not be valid. Now, I am not a large language model engineer, but it seems to help force the system to really think about the validity of a solution before it recommends it to you. I'll give you a concrete example. I was having a hard time recently in a React Native project getting it to properly compress the audio and send it to my backend. And it kept giving me the same attempted solutions to the problem, which kept failing. Simply asking the system to give me 3 different approaches that might explain why it was failing and what I should do about it, it immediately gave me a solution that actually worked. And bonus points if you have it actually rate on a scale of 1 to 10 why it thinks this is the likely solution to the problem. So when in doubt, ask it to consider multiple approaches. Tip number 7, evaluate your outputs against a standard. When you think about like AI agents, a common pattern that they have are evaluator optimizers, meaning you get an output and you ask a different agent to evaluate that output and give you critiques on it. It then sends that to a different system, the optimizer, that fixes the problem and sends it back to the evaluator. And that loop continues until you have a quality output. And so this is actually a surprisingly useful method that we can use when we're vibe coding. For example, let's say we give our app a style guide to use, but it's still producing shitty, ugly components for us. We could ask the system to evaluate that output against the style guide and against our aesthetic standards. Or maybe it builds us an authentication system for our app, and we want to make sure that authentication system actually follows best practices in the security space. We could ask the system to evaluate it against known best practices and vulnerabilities. Bonus points, you can use an MCP server like Perplexity or XAI. Go out and search the web for what those current up-to-date best practices actually are. So evaluator optimizer workflows are great ways to refactor your code, make them better, and get better quality outputs over time. Tip number 8, model selection. Fact of the matter is, certain families of models are better at coding than others. For example, Claude 3.7 Sonnet Thinking is widely considered to be one of the best LLMs for coding, though some of Google's thinking models are starting to get a lot of attention recently. Or maybe you prefer something else entirely, like open source models only. Well, swapping between these models intelligently can often help get a better solution than any of them could separately. An app that's actually a really good example of this concept is Manus, the general AI assistant app that people are kind of going crazy about. It doesn't use just one model. It combines different models to handle different tasks in different orders in order to arrive at an ideal outcome. I use Claude 3.7 almost exclusively for my planning and architecting, but if I run into a bug that I just seem to hit time and time and time again and Claude isn't figuring it out, I will switch to other models to help break through some of those barriers. Kind of think of it like pitting them against each other. Tip number 9, project rules. One of the big unsung heroes of these AI coding tools are the project rules. Project rules allow you to create safeguards and guidelines for how your app gets developed. They get passed as context to the LLM, so that anytime you run a prompt that matches those rules, it gets sent along with the prompt you give to Claude or Google or whatever tool you're using. So at the very least, I recommend having a front-end rule set, a back-end rule set, and a style guide rule set. Now there's a really awesome tool called cursor.directory that is a giant repository of different rules that you can go and check out based on what your project actually is. And if you want to get fancy, you could break those down even further. Database schema rule sets, general coding best practice rule sets, performance optimization rule sets, state management rule sets. The sky's the limit. You can break that down as much as makes sense for you. So project rules will help create serious consistency across and within projects. And it will help make sure you're implementing best practices more often. Tip number 10, potentially my favorite tip of them all, task planning. So following on that whole concept of the 4-step planning process that I mentioned earlier, task planning is the last step. Now, some IDEs like RuCode, for example, kind of support this type of stuff out of the box. But I've been really loving this open source tool called Claude Taskmaster, which can take a very large project, right? The output of stages 1, 2, and 3 in our planning process, and it can turn it into a granular, step-by-step, very detailed task list. So whatever tool you choose, task planning is an absolute must, right? If you were to think of what is the strength of a tool like Replit or Lovable or V0 or all of those other kind of hands-off tools, it's that they do that detailed task planning for you and you just don't see it. It's kind of obfuscated under the hood. So why is this important? It's because it connects your overall project architecture, meaning the specific way that we just spent all this time planning the tech stack and how it's going to all connect together, to the actual line-by-line coding that is about to take place. We make sure it is all cohesive and works with one another. One of the things that's awesome about Claude Taskmaster is it will actually recursively go back and update its requirements if it just implemented code that is going to impact something else. And so this makes it a lot easier to develop your code over days or weeks because you can keep track of exactly where you are, what you've done already, and what you need to do next. Not to mention, it keeps you from building the same thing twice in different pieces of your code base, which wastes time, which wastes money, and which creates a lot of frustration when you get into debugging things and the LLM is auto-selecting the wrong context because you didn't realize that you created a file that does the same thing twice. Tip number 11, design first approach. One of the biggest changes that I made to my vibe coding process over the last few months is to design my screens and the different states of those screens before I start coding features. Meaning I want to think through first, how is a user going to experience this app? What does it look like to them? How should screens change depending on what they're doing and the state of what they're doing? What are the different types of interactions they can have with each screen? What happens when it's a blank state? What happens when there's an error? What happens when there's a success? What happens when a user takes a positive action that we want them to take for the first time? How do animations impact the overall experience? We want to start thinking through these things for each individual feature before we start building the feature. Because you don't want to go and build something and now you realize that based on what you want to do next, now you need to go reverse out of decisions you made. And so this is how it works in like actual SaaS companies. A product designer develops design systems and specific screens and specific state indications. And then a developer implements those systems and screens and state indications. And so this makes it a lot better for us because then when we get down to writing code, it's just a matter of implementing this very well thought out thing. Now that can still take time and there can still be struggles on that path, but at least it is very clear what we're working through and why. And so again, I've got an entire video of that series of prompts and how they chain together and all of that stuff inside of the free course that you can access. Tip number 12, pick a development tool that actually meets you where you are at. So an IDE is an integrated development environment. You think of tools like Windsurf or VS Code or Cursor, they are IDEs. Ever since I started creating videos about IDEs a few weeks back, it's like I opened up a can of worms that I was not expecting. Cursor, Windsurf, Augment, C-Line, RuCode, everybody's got their favorite flavor and they will tell you how they feel about it. So RIP the comment section. Everyone's got their thing, and I do really think that that's cool. The world becomes a better place when smart people compete to make things better. My advice is to pick a tool that makes sense for you and your experience level, the context of your life, your budget, and again, what makes sense for you. Don't feel like you need to use a specific tool because you see an influencer that you follow using that tool. Because there might be something about their background that makes that tool better for them, but does not make it better for you. For example, if you're super new, you want to really start learning to code, you're not like super experienced with it, and you're also not super flush with cash, Windsurf or Cursor, probably a great option. If you're a little bit more experienced with things, and maybe you're not as like concerned about the immediate like resource management of how much cost one of those tools might actually have for you, but you want like really robust context limits on the stuff you're doing, RuCode or CLine might be a better option for you. I'm personally a brand loyal type of guy in all things I do in my life. When I find a good company that builds something cool that I enjoy using, I use a lot of their shit for a very long time. And so if you're the same way, pick a tool that you vibe with, pun intended, and just remove that burden of perpetually trying to think about that there might be another tool that's actually better for you right now. Because to be honest, it's a waste of time. Tip number 13, create custom modes for custom use cases. One of the things that I really love about a lot of these tools is that they have custom modes, meaning you can have a specific flavor for different tasks. So for example, inside of RuCode, you could have a debugging mode that's trained on your ideal method for solving bugs, where maybe you can ask it to give you 3 different solutions to a problem. Shout out to tip number 6. We see you. Or maybe you have an architect prompt that's trained on your ideal method for brainstorming a broader feature. Point being, you can take these frequently used system prompts that you tend to use in your day-to-day workflow, and we can codify them into instructions that we use again and again and again. And so one of the things that I actually really loved about RuCode is that they have a pretty extensive custom mode system that are actually pretty highly customizable, and they're built right into it. So you could come through here and change the role definition or change the instructions that it uses to architect a solution. So this one is a major workflow win for faster development and more predictable success. Tip number 14, always configure up-to-date documentation. This space changes so quickly that if you are not using up-to-date docs, you are going to have a bad time. Luckily for us, there's 3 pretty solid ways that we can make sure we have up-to-date documentation. So number 1, Cursor and Windsurf have a direct option for indexing docs. All you need to do is come in here and select Add New Doc, and then you type in the URL to the documentation, and it goes. So it's going to move through those pages, and it's going to index them. And now if you think that the documentation has updated, all you need to do is come in and hit this re-index option, and it is going to go through and index everything from their documentation. So for example, with this Magic UI, 103 pages have been indexed and can be used. Number 2, you could just manually scrape those docs. And then what you do, you put them in a folder in your project directory. And then when you want to use that tool in your coding workflows, you can just go to Add Context and choose the folder that has all of that documentation in it. So if this was Supabase, for example, we could provide all of the Supabase docs, and then we could say, go build our authentication system. And it's gonna go out and it's gonna do it with the context of those docs. And so last but not least, you could use an MCP server like Context7 to pull up-to-date docs directly from their database and inject them into your project. Whichever you pick, I recommend updating that every time there's been a change, or if you just haven't been coding for a while and you want to make sure you don't know if there was a change and you just want to make sure it's up to date. Because wasting time and resources vibing away on out-of-date documentation or SDKs or APIs is a huge pain in the ass. And let's face it, most people don't like to sit around bashing their head in frustration into their keyboards. Tip 15, add early returns and logging when you're debugging. So a huge pro tip when you are debugging code or building functions is to ask the system to add in early returns and robust console logging. LLMs are actually surprisingly good at solving a problem when you give it the logs of what is happening at each execution stage in order of your code. It can hone in pretty quickly on the things that are going wrong and what it needs to do to actually solve that. And bonus points, if you're using one of those custom modes, you can actually add that in as part of your custom mode to add robust console logging as it begins to debug a problem. And so it's gonna save you a ton of time and help you avoid a lot of frustration. Tip number 16, using checkpoint restores. I still hold that one of the greatest contributions to the vibe coding universe is checkpoint restoration inside of a chat. Inside of Cursor and Windsurf, we have these options to restore to a checkpoint. And so this is kind of like the poor man's version of a code commit or reverting back to a previous commit after something breaks. But it works well when you're vibing. So if you run into any problems or something breaks unexpectedly, you can easily revert your code back to the way it was before you made that change. And so that gives you time to, number one, commit the change for real this time. And number two, think about how you might prompt it differently to avoid that problem happening again. Because nothing is worse than having a perfectly well-functioning app fall apart at the seams because you decided to give one or two overly ambitious prompts that imploded on you, especially if you have no clue in the world how to get it back. Tip number 17, understand it before you accept it. I would honestly recommend getting into the habit of actually reading the code that AI is generating for you. And if you're feeling especially daring, you could ask it to explain how the code works or what certain pieces maybe that strike your interest actually mean. One thing that you will find as you get more experience with the coding side of vibe coding is that you can often spot a problem before the language model does. Because for all its greatness, sometimes these things just miss like plainly obvious problems. And when you tell it that, it says, yeah, that was a really good point. You're right. I should do it that way. That is what's creating this problem. I should have seen that. So getting to a point where you're really actually understanding the things that are going into your project will really help you avoid a lot of those situations in the future and just overall get better at this. Meaning spending less money on needless requests and honestly being able to solve more difficult problems because you actually understand what is going on. Tip number 18, MVP it, then enhance it. Yes, the proverbial MVP. If there's one tip on this list that I should honestly listen to more of myself, it is this one, to actually build an MVP first. Especially if you follow a robust vibe planning system like the ones I've alluded to a few times in this video, you often get these really robust long-term development plans. But it's really important to stop and think, what is the simplest version of this thing that I could build that someone would actually find valuable? You need to avoid the temptation to build the entire thing at once. I once spent a year and a half with a business partner building an entire application that we could have launched to users in pieces, only to find out that the users didn't even use 75% of the features we built. You want to avoid that situation because you don't want your life-changing project to end up in the dumpster pile of half-completed projects because it got too unwieldy and wild for you to deal with. And that can happen pretty fast when you're letting AI whip up a bunch of code that you're committing into the system without even reading it or attempting to understand what it even does. So again, take the time to think, what is the simplest version of this thing that would actually be valuable? Build that first and then hook all your other cool shit into it. Tip number 19, clearly identify your tech in your project rules. Another annoyance with some of these AI coding workflows is when the LLM decides to randomly inject redundant libraries or tools into your project in order to solve a problem. Doesn't feel like finding the right icon with React Lucid? Why not just install the Feather Icons library and start picking icons from there? So this is especially problematic when you start getting into tech that you don't really understand that well. You start off with, one ORM that you're using with Supabase, and unbeknownst to you, halfway through the project, it starts using a different one. And so you want to avoid that situation like the plague. And the best way to do that is to use project rules where you're clearly specifying what your tech stack is and what those pieces are used for. Tip number 20, security checks. On the topic of evaluator optimizer workflows that we talked about earlier, I recommend spending time to run security checks. Again, especially if your project rules aren't configured with security in mind, you might do something stupid, like sending your authentication tokens through front-end requests. And then next thing you know, your app is hacked and your users hate you. And so one nice way to avoid this is having a process or a workflow that you can run to regularly evaluate critical pieces of your code base against known security best practices, vulnerabilities, and risks. Because nothing would be worse than busting your ass to build some cool app that you really love, get users in it, and then lose all trust because of something that you could have taken time to avoid. Last but not least, tip number 21, creating new conversations as needed. So on the topic of context, a lot of these AI-powered IDEs send your entire conversation as context to the language model. So this actually becomes painfully obvious if you're using a tool like RuCode or CLine. 1 second you're at 10,000 tokens used, and then you ask one simple question, and it jumps to 25,000 tokens and then 46,000 tokens. It's because these tools are often passing the entire conversation as context. Something that I find super useful is finding natural breakpoints to just create a new conversation. As in, if it's not actually necessary to have the entire context of what you just talked about in the prompt that you're about to ask next, you should probably just move to a new conversation altogether. And so this will also help you become more deliberate and concise with how you're developing things and how you choose to move from one task to the next. Because swapping to a new conversation kind of implies that you've reached the end of a certain chain of thought. You should commit that change and now move on. See that? Coming full circle back to the commit often. So that's it, guys. You know, this video was actually valuable for me, and I'm sure it was for you too. If you want more content like this, subscribe to the channel. And again, if you want all of those prompts that I mentioned throughout the video, which are entirely free, you can get access to them in the school group below this video. But that is it for this one, and I will see you in the next video.